The first step to understanding the disease that we call asthma is to understand how air enters and leaves the lungs in both healthy individuals and individuals who are suffering from asthma. So let's just review that. So you might already know that air enters the lungs via the mouth and nose. That's the first step. And then it passes through a set of tubes. The main one that enters the lungs is called the trachea. I'll write that over here, the trachea. And the trachea then branches into two main stem bronchi. And I'll write that down here. Bronchi. And then those bronchi branch further into bronchioles. And those bronchioles are really big players in the disease that we call asthma. So remember that name, because it's very important when we're talking about asthma. These are the bronchioles, because this is really where all the action is when we're exploring asthma. Okay, now this is also a very important point. The trachea is held open by rings of cartilage, and you can actually feel those rings of cartilage if you rub your hand gently across the front of your throat. You'll feel kind of some ridges, and those are rings of cartilage that hold both the trachea and the main stem bronchi. These rings of cartilage hold these tubes basically at a constant size or a constant diameter, so that these guys don't change much in size. Now, the bronchioles don't have that reinforcement, and they're actually designed to change size according to the needs of the person breathing in and out. So let's look at how that happens. If I draw the lungs of this person in here, and I'm going to draw them a bit bigger than they actually would be. These are our lungs. And the lungs are actually surrounded by something called a pleural sac. And the pleural sac is not really a sac, it's a potential space. So that means that it could be filled with something, but it's actually, in a healthy person, just two membranes that are folded in on themselves, and those membranes have a little bit of fluid inside of them. So only in bad situations, like for example, if a person gets stabbed, or if they're in a car accident and they break a rib and that perforates this pleural cavity, that's when this potential space could become a real space. The function of the pleural cavity is to kind of reduce friction between the rib cage, and the rib cage is made up of bones that protect the lungs. I'll just draw a few of them in here. I'm not drawing these going all the way around. They actually do come all the way around and join at the sternum in the midline. At least the upper ribs do. There are some floating ribs down below, but we'll just draw them in halfway so we can see what's going on in the lungs. And the pleural cavity reduces the friction as the lungs move back and forth across these ribs. But what the pleural cavity does is it keeps the lungs tightly opposed or snugly fitting up against the rib cage while still allowing them to move freely back and forth. So let's now look at what causes, for example, a person to draw air into their lungs. And we'll start by looking at inhalation at rest. So when you're quietly sitting on your sofa, there is a very important dome-shaped muscle. And the pleural cavity also keeps the ribs tightly in contact or tightly in apposition with this muscle called the diaphragm. And this muscle is, in its relaxed form, is a dome-shaped muscle. And at rest, when we want to draw air into our lungs, this muscle contracts. And it doesn't become flat, it just becomes less dome-shaped. And because it becomes less dome-shaped, so it moves down from its original position, the result is that the volume of the thoracic cavity increases. And when the volume increases in a space, the pressure decreases, kind of like a vacuum. And the result is that air is going to enter the mouth and pass through these tubes to enter the lungs in order to equalize the pressure on the outside, the atmospheric pressure, with the pressure on the inside of the lungs. That's inhalation at rest. And we're using a muscle called the diaphragm. What about when we're doing physical activity? And so I'll just write exercise here. Now, during exercise, we need to recruit other muscles to help us get air in faster. And the muscles that we use to do that are called external intercostals. As the name would suggest, they attach on the external surface of the ribs, in between the ribs, and they pull the rib cage upward and outward. These are the external intercostals. So again, by doing this, they basically pull the rib cage up and out, and they help increase the volume of the thoracic cavity, thereby drawing even more air in to equalize the pressure on the inside and the outside. Another set of muscles that's used during exercise are the muscles of the neck. So we have a bone called the clavicle. You might know it as the collarbone. And the clavicle is actually attached to the head by muscles. Sternocleidomastoid is one of them, but we'll just write muscles of the neck. And the muscles of the neck, when they contract, what they do is they pull the clavicle upward, and that also helps to increase the volume and get more air in to this thoracic cavity. So let's now look at what happens when we want to exhale. So this is an interesting thing. Exhalation at rest, when you're sitting on that sofa and you've just, without even thinking about it, you've taken a breath in and now you want to exhale that air. So at rest, guess what? No muscles contract. There's no muscular contraction required to exhale at rest. Instead, what happens is that the diaphragm relaxes and moves back up into its original dome-shaped position. And that relaxation of that muscle, as well as the elastic recoil of all this lung tissue, so this lung tissue is going to recoil back into its original position. And those two things, the elastic recoil of the lungs and the relaxation of the diaphragm, are all that it takes to cause exhalation at rest. So I'm just going to write here, no muscles contract. No muscles contract at rest to get air out. But if you are exercising and you need to get air out fast so that you can get the next breath in, then again we have accessory muscles coming into play. And those muscles are the internal intercostals. The internal intercostals, they attach on the inner surface of the ribs, in between the ribs, the internal intercostals. And what they do is they pull the rib cage downward and inward. So they are going to reduce the size of this thoracic cavity or this thoracic cage. And because they're going to reduce the size of this space, they're going to increase the pressure, and that is going to result in air leaving the lungs and being breathed out. The other accessory muscles that are involved in active exhalation or exhalation during exercise are the abdominal muscles. And how does that work? Well, the abdominal muscles, when they contract, what they do is they push the contents of the abdominal cavity up. They push all the intestines and everything up onto the diaphragm, and that helps to sort of reduce the space here and push more air out of the nose and mouth. So just to review that all, we have inhalation at rest involving the diaphragm, this dome-shaped muscle over here. The diaphragm contracts, and when it contracts, it shortens. All muscles shorten when they contract, and it shortens into this shape, a less dome-like shape, and that pulls the lungs downward and draws air into the lungs. During exercise, the external intercostals, those ones over there, they pull the rib cage upward and outward, thereby further increasing the volume of the thoracic cage or the thoracic cavity, and the muscles of the neck also pull up on the clavicle, and that further increases the volume here. During exhalation at rest on the couch, nothing contracts. The diaphragm just relaxes and moves back into its original position. During exercise, 2 sets of accessory muscles are recruited. The internal intercostals, the ones right here that pull the rib cage downward and inward, and the abdominal muscles, which push the contents of the abdominal cavity upward against the diaphragm and help to sort of push air out through the mouth or nose. Now, and the final thing that we need to talk about that regulates airflow into and out of the lungs are these bronchioles. Remember how I said they weren't being held open by the rings of cartilage like the bronchi and the trachea? What they do have in their walls, and this is specific to their function, is they have smooth muscle in their walls. That means that if we took a cross-section of one of these guys, so if I drew a square and I made a cut through one of those bronchi, you would have something that looked a bit like this. You'd have a tube made up of connective tissue with smooth muscle cells in its wall. And that means, by definition, that there is some contractile capacity to these tubes, because if this muscle were to contract, this tube would become smaller. There's also some mucus lining these tubes to kind of catch any bits of debris that are breathed in. And because of this contractile ability of these tubes, we have another way to modulate or regulate the amount of air entering or leaving the lungs at any time.